Did you know Earth has a secret stash of water locked away deep beneath our feet? I'm not talking about underground lakes or hidden aquifers. This is something entirely different. Scientists have just discovered that a humble mineral, talc, the same stuff you find in baby powder, can trap massive amounts of water inside its crystal structure, forming what you could call superhydrated crystals. Let me break this down. Deep in the oceanic crust, talc is pretty common. But when it heads into the hellish conditions of a subduction zone, think 60 miles below the surface and temperatures around 350 degrees or 662 degrees, it undergoes a wild transformation. Under the right conditions, specifically if there's salty, slightly basic water around, talc swells up and forms what scientists call the 15 angstrom phase. In this phase, the crystal literally expands by 60%, stuffing 3 layers of water molecules between its atomic sheets. Here's the mind-blowing part. This superhydrated talc holds about 31% water by weight. That's 8 times more than regular talc. So imagine, rocks acting like sponges, dragging surface water far deeper into the planet than we ever thought possible. But this new phase doesn't last forever. As talc gets pushed even deeper, down to about 103 miles, it can't hold on to all that water anymore. The structure shrinks back to a 10 angstrom phase, squeezing out 2/3 of the stored water into the surrounding rock. That sudden water release isn't just a chemical curiosity, it can have massive effects on the geology above. It lowers the melting point of rocks, weakens faults, and might even help trigger volcanic eruptions or influence the patterns of earthquakes in these subduction zones. Now, what's really cool is how researchers figured this out. They recreated these extreme conditions in the lab, using a diamond anvil cell to squeeze their talc samples, and blasted them with powerful X-rays to watch the crystals change in real time. They found that it's not just heat and pressure that matter, but the chemistry of the water. The right mix of salt and mild alkalinity is key to unlocking this water-trapping phase. Field data backs this up too. In certain cold subduction zones, scientists noticed earthquake counts drop between 47 and 78 miles deep, just where the 15 angstrom phase is doing its thing, then spike again deeper down, right when the talc lets go of its water. It's a tantalizing clue that this mineral transformation could actually be shaping the places where earthquakes happen and volcanoes form. So why does this matter? Well, if talc and maybe other minerals are secretly hauling water deep into Earth, we might have to rethink our models of how water cycles between the surface and the depths. This could change our understanding of everything from where volcanoes erupt to how continents evolve over millions of years. And get this, geologists are now hunting for signs of this superhydrated phase in ancient rocks, and geophysicists are looking for its fingerprints in seismic data. It's like a treasure hunt, but for water hiding in plain sight, deep below the ground. The takeaway? Earth's deep water cycle is way more dynamic and mysterious than we realized. The next time you think about water on our planet, remember, some of the most important reserves might be locked away, invisible, stored in the tiniest spaces inside ordinary minerals, waiting to change the world from the inside out.